Hello and welcome to PsychBoost. In this video we'll be looking at levels of measurement. We'll talk about the differences between ordinal, interval and ratio data. Levels of measurement are different types of data. Now these different types of data are at varying levels of precision, and you'll understand this as I go through each one of them. So nominal data is data that we can place into separate categories, but we can't really talk about the differences between each category. So some categories could be pet choice, culture, gender, ethnicity or career choice. So if you think of some pets, like a cat, a goldfish, a dog, a llama, we can record people's pet choices and maybe record them in a frequency chart and display them in a bar chart, but we can't really judge each category against each other. For example, we can't say a dog is worth half of a fish. We can't say a llama is a quarter of a cat. The categories simply don't interact with each other in that way. So we can have a frequency count, which is a count of the number of items in that category. So that would be nominal data, data in separate categories. The next level up would be ordinal data. So this is data that we could order in some way. We're not going to say that the difference between each point is the same, but we can say that one is perhaps more than the other or less than another. So an example could be a Likert scale. This is like a scale between usually 1 to 7, though maybe 1 to 10 or 1 to 5. And you could use it to record, for example, happiness. How happy do you feel on a 1 to 7 scale? While it's undoubtable that a 7 on the Likert scale would be more happy than 1, but the differences between each point is a little vague. Can you really say that a 2 on the Likert scale of happiness is double a 1? Or a 3 is half as happy as a 6? We can't, it's too vague. We just have to accept that some numbers are higher than others. Other examples might be the difference in height. So in a classroom you have people of varying heights, you can order them from the smallest to the largest person. But the difference between each person isn't always going to be the same. You're not going to go up in the room and you're not going to go around the room and each person be 2 centimeters taller than the last. But we can certainly say that one person is taller than another. And another example is first to fifth. Maybe you have a writing competition and you can say, well, this is the best essay and this is the second, third, fourth, fifth. And you can say, I've made a judgment between them about which is the best essay. But the difference between the best essay and the second best might not be the same as the difference between the fourth and the fifth. So our measures, they do relate to the same variable and we can put them in ascending or descending order, but we just don't have a consistent difference between each point. Our next level of measurement will be interval or ratio data. Now interval and ratio data are different, but for everything we need to do in psychology we can treat them as the same. So interval and ratio data is data which is measured using equal units of measurement. So there's equal intervals between each point. So some examples will be millimeters. If you measure length in millimeters, 1 millimeter is half of 2 millimeters and 4 millimeters is double 2 millimeters. A drug in milligrams, speed in mile per hour, age in years or temperature. These can all be measured with interval and ratio data. So we would say that the level of measurement is precise. Just out of interest, the difference between interval and ratio data is ratio has an absolute 0 point. So this would be length in millimeters, speed in miles per hour, age in years. So what wouldn't be ratio data would be, for example, temperature in degrees C. You can have -4 degrees C. So that would be interval. But the difference between 1 degree and 2 degree is still the same as the difference between 5 degrees and 6 degrees in centigrade. So as a little activity, on the right there is a picture of a race. Now what I want you to do is I want you to think about nominal data you could use to describe this picture, ordinal data you could use to describe this picture, and interval and ratio data you could use to describe this picture. Pause the video, jot them down, and then unpause the video. So here's some information that I've overlaid over the image. This is the 2008 Men's 100 Olympic, and as you can see this is the one where Usain Bolt won by an absolute mile, and I've chosen this in particular to talk about the differences between some of the levels of measurement and how some are more or less precise than others. So one thing we might want to do is talk about some nominal data. So a piece of nominal data about these competitors is their country of origin. We have some from Jamaica, we have some from the United States, we have some from Trinidad and Tobago, and we have someone from Netherlands Antilles. Now what nominal data can tell us is that there are more people from Jamaica in this race than there are from the other countries. There are 3 from Jamaica, 2 from the United States, 2 from Trinidad and Tobago, and 1 from Netherlands Antilles. This doesn't tell us anything about who won, or what order, or the times. But this is all we can say with nominal data. We can't compare the countries in any other way but to say there are more from one than the others. Our next level of data would be ordinal data. So what we could say is the order in which they finished the race. Usain Bolt came first, then Richard Thompson, then Walter Dix, and you can continue this down from rank 1 all the way to rank 8. Now, of course, what this can't tell you, which you can see very clearly in the image, is while it's giving us the order, it isn't telling us the story of the race. It isn't telling us how much Usain Bolt was in front of Richard Thompson. For all you'd know, there'd be an equal distance between them, because ordinal data can't give us any more detail than that. So our next level down will be interval data. That'll be time to finish the race. And we can see here we've got the time to finish the race down to the hundredths of seconds. We can see here that the difference between the first place Usain Bolt and Richard Thompson is 0.2 of a second, whereas the difference between Astapher Powell and Michael Frater is only 2/100ths of a second. So our ratio data gives us a much more precise story of the race. So I hope you enjoyed this PsychBoost video. Please, if you haven't already, click subscribe, and if you enjoyed this video, give me a like. If you have any questions at all, pop them in the comment box and I'll try and get back to you. If you'd like the free resources that come with this course, I put the posters and some other things into this Dropbox link. Until the next video.